Okay, so let's look at the back side of your review. So I've still got the unit circle, my calculator, ready to go. So number 6 says here's a unit circle, point P is at 1, 0. Using sine and cosine, express the exact coordinates for point Q in terms of the angle theta. So not much work to do for number 6. So the exact coordinates here for Q are going to be whatever the cosine of theta might be. We don't know what it is because we don't know what theta is. And then the sine of theta. All right, and then that's it. On number 7, find a negative angle. It should say whose cosine Find a negative angle whose cosine is equal to the cosine of 7 pi over 4. Explain why they're equal using numbers, words, and pictures. So on the unit circle, 7 pi over 4 is down here. So any angle that also lands right there is going to have the same cosine and the same sine. So I'm just going to draw a little unit circle. I'm going to label this point as 7 pi over 4. Okay, that's the angle for that point. And so if whatever is right above it, which happens to be pi over 4, if I went this pi over 4 in a negative direction, so this way, I would also land right here. So I know negative pi over 4 also has the same cosine, actually also the same sine value as 7 pi over 4 because it would land in that spot, same spot, and so share the cosine and sine values. All right, number 8. So there's a discussion between Jonah and his classmate Keisha about the graph of y equals the sine of theta. So 2 things we know about y equals the sine of theta. I know that when theta is 0, the function is 0 because I know the sine of 0 is 0 because of that would be the starting point right on the y-axis where sine is 0. So these both start in the right spot. But then I also know about the sine of theta that the period is equal to 2 pi. So when I look at all of the positive values, all of the negative values, this one goes from 0 to 2 pi, whereas this one cycle goes from 0 to pi. So this one also has a period of 2 pi and starts in the right place. So whoever said A, looks like Keisha, is correct. B is not correct because although it starts in the correct place, it only has a period of pi. So it is not the one. Okay? All right. Now I'm going to graph the cosine from negative 2 pi to 4 pi. Oh, it's a lot of graphing. I probably won't do the whole thing. But cosine, I know the cosine of 0 is equal to 1. Again, if I look at my unit circle, right here at an angle of 0, the cosine, the x value, is equal to 1. So the cosine of 0 is equal to 1, which means there's a point right up there at 0, 1. And then it takes 2 pi to go all the way around and complete one cycle. So it has a period of 2 pi, which means it also ends here. At pi, the cosine is negative 1. And again, we can see that here at pi, the cosine is negative 1. And then between 0 and pi, at half a pi, cosine is 0. And it's 0 again at 3 pi over 2, or 3 halves pi. So that means, right, there's a point here and here at 0. So this is one cycle, and every other cycle will look just exactly like this. So the next one starts at 2 pi, ends at 4 pi, 3 pi is in the middle, and then it has those points at 0. And then right before it, negative 2 pi to 0 would make a full cycle. And there's the middle down at negative pi, and then those 0 points here. So I guess I did graph the entire thing. All right, 11, explain why the tangent is undefined at pi over 2 and 3 pi over 2. So basically, the tangent of an angle is equal to its sine divided by its cosine. And this at pi over 2, I'm just going to draw it over here. So up at pi over 2, which is right here, this is at the point 0, 1. So cosine is 0, sine is 1. And then 3 pi over 2 is at 0, negative 1. So for both of those angles, when you calculate the tangent, you end up dividing by 0. So since the cosine at those two angles, the cosine is equal to 0, you have to divide by 0 for tangent, and that is why it's undefined, because you can't divide by 0. All right, next. Name at least 3 angles for which the cosine of theta is negative. One must be greater than 2 pi, and one must be a negative angle. Okay, so 3 angles where the cosine is negative. So the cosine is negative on the left side of the y-axis. All of these have negative cosine values. So you can name any one of these: 2/3 of pi, 4/3 of pi, 5/6 of pi, pi itself. Any of these have a negative cosine. That would be 1. Now, if you had to have one that's more than 2 pi, why not just add 2 pi to this? So I could say, I'm just going to make this easy. Pi has a cosine of negative 1. 3 pi is greater than 2 pi and also has a cosine of negative 1. And then 1 has to be a negative angle. Well, what about negative pi? Negative pi, that means we just go in this direction, still end up here, has a cosine of negative 1. All right. Okay, so on number 12, we have this point on the circle at 1, 0. So this is just like the unit circle. For each rotation, determine the distance that P travels. So for a quarter of a rotation, it's going to travel a quarter of the circumference. So since this has a circumference of 1, or sorry, a radius of 1, then the circumference is equal to 2 pi times 1, which conveniently is just 2 pi. Okay, so for a quarter of the circle, a quarter of 2 pi is going to be 1/4 times 2 pi. And I showed you how to do some of these in the calculator earlier. I'm going to do that again. 1/4 times 2, math, enter, enter. So 1/2. So the distance is going to be 1/2 pi, or pi divided by 2. And to put that into decimal form, I'm just going to multiply that 1/2 by pi, and I get about 1.57. Okay, for the next one, I don't even need a calculator. I know half a rotation is pi, and I know in decimal form, pi is about 3.14. Okay, 3/4 of a rotation, 3/4 times 2, math, enter, enter. That's 3/2 of pi, or 3 pi over 2. Now again, I'm just going to multiply by pi, and I get 4.71. Okay, I'm not going to, well, I'll finish it. A full rotation is 2 pi. 2 pi is about 6.28. I just doubled 3.14. And then 1.5 times 2 is 3. So 3 pi, and 3 times pi, oops, I'll just do it that way, is about 9.42. Okay, so this one was, because the radius was 1, this also ends up being the angle of rotation. So that's kind of convenient. So then what if the radius is 2? So if the radius is 2, so if you kind of like think about how this table worked, where the distance is the same as the angle of rotation if the radius is 1. So if the radius is 2 instead of 1, then all you have to do is take this angle of rotation, 2 pi over 3 radians, and multiply it by the new radius. On C, 8 pi over 3 for a radius of 5, you multiply them. Okay, so I'm going to go ahead, I'm not going to put the pi in, so 2/3 times 2 is 4/3. So this is going to be 4/3 of pi, or 4 pi over 3. And then 8/3 times 5, math, enter, enter, is 40/3. So this is going to be, you can write 40/3 pi or 40 pi over 3. They're the same thing. All right, and that is the end of the review. Good luck on your test.